Hi everyone, I'm Lindsey,
I'm Chandan.
I'm Sohae.
And I'm Maya.
and this is our presentation on uncovering dog mysteries. So for our project, we chose the dog data set, and our goals were to find out whether or not dog size affects both dog intelligence and popularity in the US. We used our data visualization, and we wanted to see if one variable such as size could affect two different things, which is intelligence and popularity. So our two hypothesis questions were, does dog size affect dog intelligence, and does dog size affect popularity in the US? So the method that Chandan and I used was correlation to see if there was a relationship between a dog's size and a dog's intelligence. When looking at the scatter plot here, alone, it doesn't look like there's any relationship at all. But with the line of best fit, we can see that there's a weak negative relationship between intelligence and weight. So we used our data to find our T statistic and T critical value, and we compared them. We found that the T statistic is less than the critical value, meaning that we can fail to reject the null hypothesis. So through the visualization, you can see that there's not really a relationship, but with the coding to back it up, we fail to reject our null hypothesis, meaning that dog size does not affect dog intelligence at all.
So now moving on to statistics for our correlation. First off is the p-value. This is used for hypothesis testing and whether or not we should reject the null or retain it. If the p-value is under the alpha value, which is 0.05 in our case, that means we can reject the null hypothesis. However, if the p-value is more than the alpha value, which is 0.05 again, that means we cannot reject the null hypothesis, which is the case for us. Our p-value is 0.272, which is greater than 0.05, so we do not have enough evidence to reject the null for the p-value. Now moving on to the correlation coefficient. So the correlation coefficient represents a linear relationship between two different series. In terms of our data set between weight and intelligence, if the correlation coefficient were to be 1, that means there would be a strong positive linear relationship. If the correlation coefficient were to be -1, there'd be a strong negative relationship. And if the correlation coefficient were to be 0, there'd be no relationship at all. In our case, our correlation coefficient being negative 0.084 is pretty close to 0. However, it's slightly negative, which means that there is a weak negative relationship. Now, moving on to the t-stat versus the t-critical value. The t-statistic value determines how much the inclusions. The higher the t-statistic value is in terms of the distance from 0, the higher that chance is affecting our answers, or the lower that chance is affecting our answers. Our t-statistic value is negative 1.1, and compared to the t-critical value of 1.65, negative 1.1 absolute value being 1.1 is still less than the t-critical value, which suggests that there's not a strong correlation, and we cannot reject the null hypothesis. Now moving on to the confidence intervals. The confidence interval, depending on our confidence rate, which we chose as 95% with an alpha value of 0.05, suggests that the range that the correlation coefficient can range from is negative 0.231 to 0.066. Our, our range includes 0, which means that there's not a strong relationship. If the range were to have two positive values, that'd be a strong positive relationship, and two negative values suggests a strong negative relationship. But since our range includes a 0, it's not strong regardless. However, the absolute value of the negative value is more than the absolute value of the positive value. So that means it leans more towards a negative relationship, but it's still weak and it's not enough to reject the null hypothesis.
Okay, so now we're going to talk about, does dog size affect the popularity of a dog? So this is the box plot that we used to look at the data, and you can see that the distribution for medium, small, and large dogs, you can see how there's no big difference between any of the plots really, only with the medium dogs having a wider range, but other than that, you can tell the mean and range is about all the same with the different dog sizes. The box plot pretty much gives you an idea of what the conclusion is going to be, with the box plot pretty much matching up.
In one-way ANOVA, which we use to figure out whether there is a relationship between dog size and the popularity, the sum of squares between groups signify the variability in popularity scores among different dog size groups. This value is derived by calculating the square deviations of each group mean from the grand mean and summing the square deviations. Conversely, the sum of squares within groups represents the variability in popularity scores with each dog size group. The degrees of freedom for between groups are determined by subtracting 1 from the number of groups. Similarly, the degrees of freedom within groups are calculated as the total number of observations minus the number of groups. Mean squares are obtained by dividing the respective sums of squares by their corresponding degrees of freedom. These values plays a crucial role as components for further statistical analysis. To calculate the F statistic, divide the mean squares between groups by the mean squares within groups. The F statistic is a pivotal metric used to assess whether there are significant differences in the means of the groups. Following this, by utilizing the F between and the F within, we can choose the significance level alpha 0.05 of the critical F value. Upon comparing the F statistic with the critical F value, if the F statistic is not greater, the result would lead us to retain the null. This implies that based on the chosen significance level, there is no statistically significant difference in mean popularity scores among small, medium, and large-sized dogs.
So in conclusion, we found that dog size does not affect either intelligence, or dog size does not affect both intelligence and popularity in the US. Thank you.
Thank you.